Let's solve this question. Arrange letters of the word Madagascar such that two A's are together and other two A's are also together. So there are four A's in this word, 2A and these two A's. So it is asking that I have to arrange the letters of this word Madagascar such that two A's are together and other two A's are also together, but all the four A's are not together. In how many distinct ways can the arrangement be made? So let's just place this one packet of A together, then comes the M, D, G. Let's just place second packet of double A together, and then what are left? S, C and R. These letters are left. So this is one possible arrangement. I cannot have these four A's together. I cannot have these four A's together, or these two packets side by side and all the digits as it is. I cannot have this arrangement. I can have this arrangement that two A's are together and other two A's are also together, but four A's should not be together. So what I can do is I can find the arrangement of these letters. This is total arrangements of these letters, and then subtract number of arrangements of this setup, because in this setup all four A's are together, but in this setup all these arrangements will include when this packet and this packet are not together, and also when this and this packet are together, that is this case. So I have to subtract all these arrangements of this type minus arrangements of second type. This is arrangement of first type, that is this. So in first setup, total arrangements, I am calling them A1. Total arrangements are this is a packet of double A. I am considering, or I am treating it as a one object, single object. So 1, 2, 3, 4, 5, 6, 7, 8. So this is the arrangement of 8 objects in which 2 objects are identical. So this is 8 this is given by 8 factorial over 2 factorial. So this is the arrangement of 8 objects in which 2 objects are similar. Why? Because this double A and this double A objects are similar, and because these are similar, I have divided it by 2 factorial. Now arrangement 2, that is arrangement of this type when all 4 A's are together, or I would treat this packet as single object. So this is one object, 1, 2, 3, 4, 5, 6 and 7. This is 7 factorial, and I need to subtract this A2 from this A1. So the number of ways number of required ways would be 8 factorial over 2 factorial minus 7 factorial. These are the total number of distinct ways possible. So it would be 7 factorial common. So what I am left with 8 by 2, that is 4 minus 1. So 7 factorial I know is 5040 into this is 3. So it becomes 0 and 15. 15,120 is the right answer. So correct answer to this question is option D.